is, but we don't actually have any evidence for it. Are they going to say that?
They should also say there are
evidence. Right?
They should also say there are alternative possibilities and encourage the child to think for themselves, to investigate for themselves, instead of sucking the life out of them and basically portraying to them that everything's been figured out. Just remember this belief when actually it's deceiving them because it isn't true. It isn't a fact. It's just an idea. They should actually be like, hey, actually, here are all the problems with it. And in fact, the only reason you wouldn't explain how it doesn't work is because you're deceiving them, because someone writing the textbooks wants them to believe a certain thing. Because if it was just a free and open society in pursuit of truth, you would encourage the youth, right, to help you discover what's really going on. You'd be like, yo, like that would get them excited about learning. That was the only time I was excited in school, was like, oh, we don't know what that is. Maybe I can be the one that figures out what it is. But they don't tell children that. They don't say, well, we thought the core was this, but found out that doesn't work at all. But then we think it's this right now, but this is actually not working. And so you can figure out what it is. There are many options. It could be something we don't know at all. It could be something completely different than what we think it is. They don't teach them that, right? They teach them propaganda.
I was definitely taught.
We're taught to deny our senses. Right?
You were not taught that the Earth could be in the center of the universe. You were taught the solar system is a fact, right? You were taught that gravity's a fact and it holds you onto a ball. You were taught it's a fact the Earth spins and it's a fact the Earth moves around the sun. You were 100% told that that's a fact. You were shown a globe, and then someone in the class said, how do I not fall off of that? Everyone laughed. And they said, "Oh, silly Jimmy, gravity." And then they said, "What is that?" It's circularly what holds you there." And everyone's like, "Oh, okay.
Curious,
when is recess?"
I'm curious. Are you a Christian, bro?
Sorry, me.
Yeah, mate.
I'm a Christian.
No.
Oh, okay.
In the sense, there's a creator.
But I guess you'd say that I hold broad Christian beliefs. I'm not religious, but I have much of the same moral backing that you would expect in a Christian community.
I got a question for you, though. So let's check this out.
It's a weaponized term, just like flat Earth.
So let's think about this real fast. If we were to tell children, look, here's the deal. We got a couple options, right? Option one, the Earth is spinning, but it just feels like it's not moving. And actually, when we see all the stuff in the sky move, that stuff is sitting still. It looks like it's moving because we are moving and we just can't feel it. Option B is that the reason it feels like the Earth is not moving is because the Earth is not moving. And the reason it looks like the stuff in the sky is moving is because the stuff in the sky moves. What decision do you think they would make?
But Witsit, there's the final piece. The final piece is we've been to space and we've taken a photo of the Earth and it's clearly a globe and it clearly spins. So we know the other one.
That's begging the question, bro.
I know, but
assuming all that.
Wait. I know, but when you go to school, they're assuming that the authority is telling the truth. So that is how it would then be positioned and taught to them, right?
Yeah, but even that would be a misconception. If they had gone to space and seen the Earth's a globe, in theory, it still wouldn't prove the Earth is moving, right? So, like with the specific example I'm saying, in their model, if they went to space and looked at the Earth, it could look like the Earth was moving just because the whole universe was moving around the Earth. And my point is, we all know what the child would think, right? We all know. Now, this is where people would say, oh, that's child abuse, because they just think they're just going to accept the simpler, more intuitive option. No, it's child abuse to lie to them and tell them their whole world is inverted from what they experience, when at the top levels of academia in 2024, it is admitted that the Earth could be stationary with all of the physics, all the kinematics, all the dynamics, everything in the model admits it. But you don't tell the children that. Why? I know why. Because if you told the children that, we all know what they would choose, right? We all know they'd say, it makes way more sense that the sun is moving around us, because that's what we experience. And if you were even to open that gate to them, you would never get them back. You would never get them back. You think you're going to come back, double back around in 7th grade and be like, oh, by the way, it's all actually backwards? Of course not. that is a problem. Like, how do people not see that that's a problem? And how would anyone, this is a side note here, but the fact that anyone would suggest that telling children that truth, which is what I'm going to do with my daughter, I'm not going to tell her what to believe. I'm just going to tell her how to think, not what to think. And I'm going to tell her the situation, which is what I just said is just the truthful situation, and let her think for herself. How could anyone suggest that that's child abuse? Isn't it abusive to mislead a child into a world where they think everything is backwards, but you can't actually verify that, and to mislead them that people have proven it? When they like, if an adult told a child that that they turn into Superman at midnight, they believe it. Like, they believe anything an adult says when they're young. I mean, that's a bit of a rant, but that's significant. And we can't even get the adult Globers to level with us and admit, right, that, like, yeah, all the observations match that, and actually it could be the case, and we should tell children both options.
Yeah, and give them both options, but give them all the information. So, I was reading something the other day, which was the paper you cut a snippet from, the relational
mechanics
stuff.
Yep.
Yeah, right. That's where, as you said, that their physics shows that you can't determine whether the Earth is stationary or the universe is stationary. There's no difference because the two are completely interchangeable in their physics. But they also admit their physics is incomplete, right? That it doesn't explain a lot of things yet that we see when we look out into the space. But it does cover a number of core kind of concepts that are
like what? It doesn't explain what.
They couldn't explain
I have a
redshift,
question for the
and they
globe.
couldn't explain the cosmic microwave background. And they admitted that in their paper and some of their other stuff. And they also they don't predict some of the things that the alternatives predict, right?
I would just like to talk to you for like 30 seconds, mate. Just before we go on from here. Your whole model is a bunch of begging the question assumption fallacies, yeah? And with no proof. And we're trying to like bring an alternative view to that. And so like I don't really know like what's going on with you like spiritually or something like that. But like if you're seeking truth, bro, you have to realize that these are fallacies, bro. Like your whole structure is a bunch of fallacies. I just want to say that. God bless.
Thank you. Yeah. So just I've got to disappear in a few minutes, but the going back to what would you teach the children about the motions of the Earth, Witsit, that so you'd say to them, right, this is what I would do anyway. Imagine yourself lying on the ground in the middle of the desert in Australia, looking up the stars at night. You'd see the Milky Way rotate over you, and that gives you one perspective about how your motion might be through the universe. And then you can look at the sun during the day. That will give you some other perspective. You can also explain to them how your perspective can alter that. If you change your point of view and imagine looking at the solar system from the outside, it's equally valid to interpret the heliocentric view of things as it is geocentric. And you might say to them, well, why don't we feel the rotation of the Earth? And you say, okay, shut your eyes. I'm going to stand you on a merry-go-round, and I'm going to turn you around. And you turn them around at 15 degrees per hour. They can't feel it, right? They don't know they're turning. You say, well, this is probably why we can't feel the motion of the Earth through space.
You wouldn't say that. You wouldn't say that. You wouldn't say that's probably why.
Well,
I was in agreement with you all the way up to there.
Why, right? Yeah.
You would say that these are how the two options would work.
Yeah. So our senses about what motion we would expect to feel as humans don't work at the scale of the motion of the Earth, or not lack of motion of the Earth.
The potential
and
alternative, yes.
Yeah,
yes, I think you should tell them all that. Yes, you should tell them all that.
Yeah. So you could then show them things like have a heavy mass and something spinning off it on a string, right? And show them how the heavy mass kind of wants to be in the middle with everything flinging around the outside.
That isn't what happens.
It makes sense that the heavier stuff is in the center of any kind of rotational system. That, if you want to look at it from that perspective.
No, that doesn't make any sense. The heavier stuff just wants to go down.
Oh, no, I'm talking about something if you had it spinning, right? So say you had a
it's going to go to the outside.
Big steel ball.
The stuff's going to go to the outside.
Yeah. So if you had a big steel ball and a string and a little steel ball, and you spun it so that the string was taut, right? That the whole system's going to try and spin around that big steel ball, and it's only when the size of the second ball becomes about the size of the other ball that you start to see, that motion where they're spinning around the barycenter, and that you could say that is how we think the solar system hangs together. That the sun is heaviest in the center. All these things are in motion around the outside. And it kind of seems like the logical way that things would move.
No, it doesn't. But you can tell them the option. I've said that many times. Like, we already tell them that option, right? I'm all for telling them the option. I don't think. But a child is very intuitive. In fact, they have to have intuition bred out of them. And that's why we have a bunch of adults now that when we talk to them about this dynamic and kinematic equivalence, the fact that the Earth could be in the center, it's like their brain shuts off because they've had years of indoctrination. When you tell a child, look, option one is that we don't feel the Earth moving because it's not moving. Option two is you could be moving so slowly that it feels like you're stationary, and it's going to make the other stuff look like it's moving. Or option two is just that other stuff is moving. Okay, they're going to be like, okay, I guess it could be possibly the other one. I'm still kind of leaning towards like what I experience, right? When they go into the world and they start thinking about it, they're going to be like, the Earth is not moving. Like, I see everything else moving. Sometimes the wind blows, sometimes it's completely still. That's an absurd notion to me, right? If we're going to be honest, a child's going to think that the one that's most logical and intuitive is the truth, right? And someone actually make the argument that that's the reason that you shouldn't tell them the alternative. The second thing, if you want to come up with this idea that the sun's the biggest, you're going to tell them, but that would require that the sun actually be way, way, way bigger than the Earth, but it's going to look like it's way smaller when we look at it, right? And it's going to look like it's the same size as the moon. And you can say, so look, option one is that the sun and the moon look like they're the same size, and they look like they're smaller than the Earth because they are smaller than the Earth and they are the same size. And you could show them two things be the same size. Then you could say, and you could take a really big ball and you could walk really far away and take a little small ball in front of it and say, if you get at just the right angle and just the right distance, they can look like they're the same size, even though this big ball is really, really big. And you're going to keep stacking those things up, right? And the child's going to be like, wait a minute. Logically, it is not making sense to me that all of these crazy deceptive illusions and coincidences are stacked up everywhere I look to make everything appear to be the opposite of what it is. They're going to logically put together. Clearly, someone's come up with some way in every scenario to explain why it is actually the opposite of what I see. So even a child will be able to understand that repetitive coincidence is not logically admissible. That's the point.
Oh, you get to know me a little bit longer.
Professor Waterball. So anyway, that's the point I'm making. I'm all for transparency. Tell them every option, and that's the worst thing that could ever happen for like the spinning globe proponents. And we won't have to get on together. Like redshift doesn't work. If it's the idea that everything's expanding away from you, it doesn't work. There's anomalies. There's things that's way further away that have less redshift, things way closer with way more redshift. It's not an uneven distribution. They're saying, oh, there must be something outside the visible universe called dark flow that's pulling parts of the universe and changing the redshift and all this crazy stuff. Or no, none of that's real, and that's not why we see redshift, and it's all electromagnetic retardation. Everything's electromagnetic or in a torus field, or things further away typically maybe go through more of a medium based on the different mediums that can change. But anyway, and we're not going to teach children redshift,
That's
but
also,
the redshift hurts you. The redshift doesn't match your model at all. But you can tell them, okay, look, when we look out into space, what we see is that the Earth's in the center of the universe. It looks like everything moves around the Earth. Okay. Option 1 is that the Earth is in the center of the universe. And if that's the case, then you remember the other options we were talking about, how it feels like it's not moving. Well, that's what that would mean. If the Earth's not moving, we would be in the center of the universe. And when we look out, it's going to look like we're in the center of the universe, which is what we see. Option 2 is we are moving. We just can't feel it. And we're actually moving many different options, many different ways, right? And then we're going to look out. It's going to look like we're in the center of the whole universe. But actually, right, the universe is accelerating and expanding in all directions. And it just makes the Earth look like it's in the center. And then you can pull out a balloon and put little dots on it, blow it up, and say, see, these dots are expanding away from each other. So if you were that little dot, you wouldn't really be able to tell if you were in the middle or not. And again, logic and intuition is going to dictate, right, that repetitive coincidence is insane. And if you have to invoke repetitive coincidence to convince me my entire experience is the opposite of what is real, I'm going to dismiss it. You're going to have substantial evidence. And last thing I'll say, you say, yeah, you can put them on the merry-go-round and spin around 15 degrees per hour. How are you going to demonstrate the idea that we're going 66,600 miles per hour around the sun at the same time, and that we're actually wobbling in 4 different ways at the same time, and then we're going a different direction,
Why?
500,000 miles per hour? How are you going to demonstrate that to
But
them?
our rate of acceleration is low, right? We're not changing directions fast despite those speeds. So the biggest rate of change of direction that we have is the rotation of the Earth, right? I think that exceeds all the others. And we can't feel that.
Oh, but the point is that you're not going to be able to actually show them anything. They're just going to have to tell them, trust me, you can't feel it, bro. You're going to have to say, trust me, bro. And they're going to say, wait, what? It's not just the spin. It's like, I'm also flying through space. I just can't tell. And I'm also wobbling 4 different ways. How are you going to show the child a ball wobbling 4 different ways at the same time?
Well, you tell them that it's wobbling. Each of those wobbles some of the wobbles take a year. Some of the wobbles take a day. Some of them take 28,000 years. You wouldn't
Aren't
just
they
say
going
it's
in
wobbling
different
and tilting and squirring all over the sky, because that would be misleading, right?
But aren't
If
they
you
going in
told the
different
children that it
directions?
was-
Aren't they wobbling in different directions, even if it's different rates?
But the rates are very low. The rate of change of direction is very low.
I know, but what I'm asking you is, how is it physically possible that a ball can wobble in 4 different directions simultaneously? The rate doesn't matter. I'm just talking about like the physics.
Probably, I'm trying to think of an example here. I think we've all seen those spirograph machines, right? Where you put all the gears in and you draw circles by pushing a pen around. So those things are moving in multiple directions at the same time. But if you move them slowly, your pencil just, you can just see the tip of the pencil moving along the paper. That's all you see. You're not aware that it's going in and out if you're just to focus on the tip of the pencil, because the pencil is not, going berserk, even though the motion is very complicated. At any given point in time, the pencil is just moving slowly across the paper.
That's not analogous to a sphere wobbling in 4 different directions.
And analogous to the motion of the Earth through the solar system. It's the same kind
I'm
of
talking about the
combination
wobble.
of
I'm talking
motions.
about the wobble, bro. The wobble. Okay, the wobble.
The wobble isn't really a wobble. You're talking about the tilted axis.
They're not. The Chandler wobble's not a wobble.
The precession of the axis you're talking about now.
There are 4 different wobbles. They're all wobbles. The Earth's on a tilted axis and it's wobbling in many different ways. And by the way,
So the Earth's tilt is not a wobble, right? Because we always face the same way inertially.
but we're wobbling.
How big are these other wobbles? Can you quantify those for me?
Like you said, one of them is 26,000 years. One of them is like 17 years. One's like every 7, whatever. Yep. And they're going to claim that they're small. That's not the point, though. Like, yeah, they're small, but the point is that because they're compounding, they're compounding vectors on a singular physical object.
And the net acceleration is essentially dominated by our daily rotation around the axis.
No, bro, it isn't about acceleration.
In terms of what?
It's like, can you demonstrate a physical object? You can demonstrate that a ball can spin and move in a circle at the same time. You can demonstrate that. Can you demonstrate a ball wobbling 4 different ways at the same time? You can't. It's physically impossible.
Yeah. No, I think we might be able to. Not a ball, but imagine a spinning top, right? We've got a spinning top, a bit of precession.
You'll get two. You
and
maybe
we
can get
spun it
two
up.
wobbles out of a spinning top.
Well, we can have a spinning top spinning at an angle, right? We can sit it on the end of a stick. Most tops will have a bit of precession in their wobble due to just manufacturing tolerances. So if we've got that top and we balance it on the end of a stick and we turn around in a circle, we've got that compound movement going you've just discussed. We can lift it up and down, we can turn it, and the top will just continue on its merry way as we rotate it round.
Hey, bro,
it won't be.
Witsit, before you answer, do you understand, Daza, how far you've appealed to an extreme to prove the crap that you believe? Go ahead, brother.
Well, I want to point out to you, just so the audience knows, the way that they supposedly found out the Earth's wobbling all these different ways was that their model kept being wrong. Okay, so they get more and more precise, detailed observations of the sky, and it wasn't working because the sky's processing in a way that wasn't supposed to be. So they're like, oh, well, it must be wobbling. And then they noticed that a different part of the sky was processing a way it wasn't supposed to. Oh, well, it must be wobbling a different way at a different rate. And then they noticed that with those two wobbles and the rotation of the Earth, the moon's orbit wasn't matching what it was supposed to. So they added another wobble. They just infinitely add new motions to explain away what we see, when obviously the alternative option is just that everything moves at their own rate because they are independently moving. So one option is the Earth's not moving, everything else is moving. So of course they process their own rate, they're moving on their own. Option two is everything appears to be moving in relation to the Earth moving. Therefore, you have to put all the motion on that single object to such a point that they've actually added 4 wobbles to a singular spherical object that can't be replicated in reality whatsoever. Absolutely cannot. I've scoured the internet. The best you can get is 2 wobbles. That's the best you can get on like a actual mechanical gyroscope. You can get like notation basically, and you can get 2 wobbles. You can't get 4 wobbles. It's not possible.
And forget the 3-body problem.
3-body problem is not a problem.
Okay, let's not even get into it.
It's a huge problem.
It is a problem,
Yeah.
but
it's a problem analytically. It's a problem, right? But going back to the motions, right? Would you expect that we could just go look up at the sky with the crude instruments and go, there it is. That's the motions of everything sorted, done and dusted. What is wrong with, as time passes, providing more precise information? So broadly speaking, the path of the Earth relative to the solar system and the sky, it's the same as it was a century ago, right? We've got more fine details of those motions now, but we haven't fundamentally changed our view, right?
All right, let's see if we can talk you through this. Okay. The stuff in the sky is moving, and it's like progressing over time, right? And everything is processing and progressing on its own rate as we see everything move on its own. Okay, what is option A to explain that?
Wait, what do you mean? What is option A to describe that? To explain that?
Our observation is that we see everything moving on its own, and they move in their own rates and cycles and their own progression. What's option A? It's that they're all moving on their own. That's option A. Option B is that's an illusion.
There's nothing natural. There's nothing causing them to move.
What? Obviously, something's causing. No, obviously something's causing them to move.
Okay, yeah. Sorry, I misinterpreted what you meant by the moving on their own. Okay, yep.
Yeah, I'm independent of the Earth. So anyway, and then option B is like, oh, well, it looks like they're all moving on their own, but it's actually the Earth spinning. Logically, you say, well, if the Earth's spinning, everything's going to move together. Because it's all not moving, but we're moving, so it's going to make it all move together. But we don't see that. We see things moving separately and progressing and processing over time on their own. So then they said, oh, well, there must be like a wobble here, a different wobble there, a different wobble there, another wobble there, right? And it's spinning, and it's revolving, and it's flying through the galaxy, and the galaxy is flying through space. All at the same time. It's because it all has to be the Earth that's moving. And it got so bad that it actually is a claim that's physically impossible again, because you can't have one single spherical object wobble 4 ways. And what you're doing, basically, respectfully, is appealing to possibility. So you're saying, well, like I think like isn't it possible that could make sense? That could make sense, and that's obviously a fallacy, right? Like just because something's possible doesn't mean it's true. But it's even worse than that. You're appealing to possibility even though it's not possible. So you need to demonstrate that it's possible a physical spherical object can actually rotate or wobble 4 different ways at the same time. You need to show that it's physically possible that you can have a geodynamo model of a core that's actually causing a magnetic field that's not symmetrical on a sphere, right, at over 6,000 Kelvin. Like, my point is the globe is just appealing to globe earthers, and I understand why. It's because they were told this belief, and it's a hard thing to grasp that maybe people are lying. But anyway, this is what they're thinking, and this is like illogical. They think if I can explain a theoretical possibility that would make sense, then the globe is good. So we can still believe it's true. That's not logical, though. I can make a million things. Technically, it's possible that unicorns are at the center of the earth and that they inhale in unison, and that's what creates what we call gravity. But sometimes they run out of breath, and that's what causes gravitational anomalies. And I could just say an animal we know exists that way. I could say it's possible. Appealing to possibility is illogical, but it gets way worse when you can't even demonstrate the possibility. That is such an egregious begging the question. Do you not see the problem there? Don't you agree I'm founded in saying, okay, if you're claiming the Earth's a sphere and it's wobbling and you just keep adding them to it because your model keeps being wrong, and we just have to act like it's not wrong so for some reason, am I not founded in saying, well, at least show me that it's physically possible? Can you show me a sphere that's wobbling 4 different ways at the same time? Like, isn't that a reasonable request? Like,
Yeah, well,
I have a question.
I definitely have to understand those 4 different wobbles, what they mean. I'm not familiar with them all.
On the globe model,
And
what is the
Daza,
reason?
to be
this happens?
fair, yeah, go ahead.
Is this?
Yeah, my question is,
Can everybody jump
on
in
the
here
globe
too, or
model,
is
what
it
is the
only-
reason for the
Yeah.
wobbles?
oh, they don't
why
actually
does
claim a causal mechanism. It's just they had to add wobbles because the sky was not moving the way it was supposed to, right? Like they don't actually explain why it wobbles.
Well, that's
I
the
don't know.
question.
Well, they don't know. That's what I'm telling you. It's physically impossible. They can't tell you why.
What's the fourth? I'm aware of precession, and now I know about the Chandler wobble. What's the other one?
There's like nutation. I don't remember all the official names. I'll look them up.
Right, Chandler wobbles is an example of notation.
Yeah, there's 4 wobbles. I'll look it up.
And by the way,
Care
could
if
I
I make-
answer? I think I could do it real quick.
Yeah,
I-
Piazza, go ahead, brother.
Wait. I'm Big Tech. Could I go real quick? Very quick. There was option A, option B. A was everything's moving in the sky, so maybe everything's moving. B would be, oh, maybe I'm moving, and that's why it appears an illusion that everything's moving.
Mhm.
But I think C would be, what if the sky's moving and I'm moving? And I think that's what the globe theory is, that as option 3, everything's moving.
Sure, but like in relation to us, everything is at rest, right? So like technically the sun's moving through the galaxy, but in relation to us, it's at rest relative to
The
Earth, right?
stars are moving, but they're too far away.
Well, but no, like Mars and Venus, they're not at rest relative to us.
No, they all move in. No, we observe them
Mars
as
is
if they
retrograde
are.
because it appears that it's
Right,
like sometimes
precession.
it changes directions and stuff, and then
Yeah,
we
yeah,
find out,
retrograde.
Oh, it's
Mhm.
yeah, it appears to be a good explanation. We thought of like, oh, if it's going around the sun, sometimes it's going left, sometimes it's going right.
Yeah, it's specifically that the moon moves in its own little cycle and progresses. The stars progress over time, etc. Right, and so option A is like, oh well, the stars move on their own, the moon moves on its own, etc. Option B is all those things are appearing to change their motion over time because the Earth is doing all these different things that make them change over time. Because in relativity, it's all relative. So the sun is at rest relative to the Earth. The stars are at rest relative to the Earth.
They just told me my mic is quiet. Is it better now?
It's about
Still
the
quiet?
same.
Yeah, it's not super quiet, but
What if I can?
I don't know actually in relation to me.
They're telling
I
me they got
mean-
me at 200.
After
Maybe
Big
is
Tech
this better?
finishes, can I drop some before I get out of here?
Yeah, yeah.
Yeah,
I just wanted to.
I had a question too, but I'll wait till after yours.
Thanks, man. I just wanted to touch real quick. It kind of got glossed over earlier because there were so many things being listed, especially when we talked about the kids in school. But the merry-go-round thing that he brought up, that analogy, right? Like putting the kid on the merry-go-round and turning it 15 degrees per hour and saying, "Look how slow this is. Like this is potentially why you wouldn't feel it." Is still not really good. Like you would need to make that merry-go-round extremely, extremely ridiculously large in diameter, and then you need to spin it, and you need to show the kid like the difference in what you feel close to the center of it and the difference in what you feel at the edge of it, right? Because if anyone's ever been on a merry-go-round and played on one of those things, not the like the horses ones, but the ones at the like parks where the kids will spin it and get you going like crazy fast and fling you off, you know very well that the closer you get to the edge of that thing, the harder and harder and harder around you go, because it's your tangential velocity that matters. So they want to talk about how slow 15 degrees per hour is when you use an analogy of a clock and all that stuff, but you have to remember that you have to extend that clock arm out 4,000 miles long and then stand on the edge of it. So even though it's moving 15 degrees per hour relative to the center, it's moving around at 1,000 miles an hour, and it's always constantly changing direction.
But it's the
like a
acceleration
15-second
you
thing
feel
before
that's
you go,
important
Daza.
Velocity.
Is that I bring this up a lot, Piezo. Is that like the centrifugal force? Like, is there like stronger gravity at the equator? Like, it doesn't make any sense, bro. None of it makes any sense.
Now, the
With
gravity's about the
centrifugal
same.
force, wouldn't there need to be more gravity at the equator?
Well, I didn't want to drop.
water
I didn't want
The
to
gravity's
derail.
far bigger than the centrifugal force, right?
Hold on.
By a
I didn't
factor
want
of
to.
10.
I didn't want to derail the conversation. I just wanted to drop that clarification because, like, sometimes it gets glossed over. I don't want to like take away from what's being talked about now. I just thought it was relevant to mention because it didn't get mentioned earlier, and it was kind of just passed over as like a tacit acceptance of the rotational velocity, but not the tangential one. Thanks.
Right. But if it's supposed to be a constant, it doesn't make sense to me. Go ahead, brother.
Constant that's changing, bro. You didn't know?
I'm sorry, Austin.
If it's time for me to go,
Yeah, go ahead.
I wanted to ask. I've been seeing people asking why. I don't understand it's being posited that we need a container around the atmosphere for the gas to not escape into a vacuum. Can we talk about that? I don't understand the contention there. And how's my volume? Anybody say it's bad? Oh, they say it's well. It's
Yeah,
better.
yeah, you're good.
Yes, good.
Decent.
I mean, I can take it. I think everyone here can take it, but anyway, there's something called the second law of thermodynamics. It's known as like the most indisputable natural law that exists.
Right.
And it's basically really simply just that
Energy
system.
seeks equilibrium.
Exactly. Yeah. And through a process called entropy. And then what the actual cause of entropy is, no one knows, right? Natural law doesn't really deal with causes. It just says this always happens. So systems always seek equilibrium, and high pressure always migrates to low pressure. And so if I have like a gas pressure system next to a vacuum, the gas is going to violently fill the vacuum every single time. And
Unless something's
stopping it. Yeah, of course. But like a physical container, right? So if you invoke the ideal gas law, it uses a physical container to actually determine the pressure mathematically. The globe is claiming that gravity is acting as the container, right? And so the idea is that it's like pulling the gas down to the earth, but there's a few problems. And one problem is, well, we know gas goes in all directions, including directly up. And that's the opposite of down, of course. And it does this at the
all
surface.
directions on a globe. Every direction on a globe is directly up.
Please don't interrupt, bro.
Well, I mean, at any given point, you have up and down, right? So it goes in, it's omnidirectional dispersal. At the surface of the globe model, gravity is the strongest, right? Because it's relative to the center of mass. So the closer you get to the center of the globe, the stronger gravity is. So if I test this claim out near the surface where gravity is the strongest, and I put gas pressure next to a vacuum up higher than it, right? If I remove the lid, the gas fills the vacuum. Gravity does not keep the gas inside the chamber. Gravity, which is just assumed to be true, if we assume it's true, where it's the strongest, it doesn't stop gas from filling the available space. Yet there's a claim on the table that says where it's weaker, right? And where the vacuum is the strongest, stronger than we can even replicate on the Earth, somehow the gas is prevented from filling the available space.
Right. So where it's weakest and it's dissipating, somehow that's keeping the vacuum or the low pressure system of space. Yeah, I got you, bro.
Okay, so space isn't space is so there's not a low pressure system of space as I understand it. There's a no pressure, but pressure is created by the gravity, right? So the further you get from the surface, the lower the pressure because the lower the gravity, and
Well,
also
that's
because the lower the density.
well, for one, of course, there's no such thing as no pressure. Like, in a perfect vacuum doesn't actually exist, right? Nature abhors a vacuum. It's just an extremely low pressure system. We call it a vacuum, and
Right.
it's 10 to the negative 17 torr, which means there's just a few hydrogen atoms per cubic meter.
Right.
Like, and on the Earth, we can do like maybe 10 to the negative 6. Some claim 10 to the negative 8th. We can't even get anywhere close to 10 to the negative 17. But and you have to have like huge, like 5 foot thick cement, walls with like crazy rods in them and all this crazy stuff. But anyway,
Yeah.
But the point
Yeah.
is like, yeah, there's a gradient, right? Yes, the low pressure, the pressure gets lower the higher you go.
Mhm.
And that's what globe earthers will always say back, right? They're like, well, but we have a gradient, and that's actually skipping over the point, right? Because we're trying to figure out how do we even have the gas pressure here to then have a gradient. Like, we can replicate a gas pressure gradient in a container. That makes perfect sense. But like, how do we even have the gas pressure to then have the gradient, right? Unless there's something physically containing it. And if you claim it's gravity, well, like, we can prove that gravity doesn't do that, because where it's the strongest, it doesn't stop the gas pressure from filling the available space of a weaker vacuum. And so that's the problem. Everyone's like, oh, well, what about the gas pressure gradient? And it's like, no, we have to have gas pressure
Steel.
first.
Yep.
Hey, real quick before we segue off of this, I think if we could sub Pizio in real quick to touch on the ideal gas law and how it's based off of kinetic theory. So they don't even account for gravity in in the way that they present it. It's all based off of, a physical surface to cause pressure. So applying it abstractly to, less gravity in the sky equals XYZ. Well, it wouldn't work like that at all, because with the ideal gas law, you have the excitation is going to be based off of the heat. So it would just keep going out into space. You wouldn't have an atmosphere. So Pizio, if you can come up and go over that real quick, that would be awesome.
You're talking about
Wait, was that the totality? Do I get to follow up on? I think we're still
Yeah,
on
you
the-
can. You can. Piezo's going to kind of explain it further, and then you can say whatever.
Oh, this is on the same topic.
Are
Yeah,
you,
yeah,
are you talking about the
Yep.
the
Okay.
deep? You talking about the deviation from ideal gas law, Alan? Can you specify which part just one more time, real quick? Like which part you want me to touch on?
Yeah, so the ideal gas law and what it's based off of for their calculations, right?
Oh, okay. Yeah, so like Boyle's law. So there's like, if you look at the ideal gas law, PV equals nRT. You've got the pressure and the volume on one side being proportional to the temperature on the other side. R is just a constant, and then N is just how much gas you have. It's a number of moles, but the pressure is directly proportional to the temperature as well as the volume and the temperature. But the thing is they've modeled this, in containers since, at least 150 years ago, roughly. What's weird though is that like the ideal gas law, based on their theory of matter, doesn't actually even hold up. It's actually imprecise. It's actually always off by a little bit. There's always a little bit slightly less pressure than is expected as per the ideal gas law. And, in the kinetic theory of gases, a container is filled with these little particles that are making a collision. Like in a vacuum, right, there's very few particles, so there's very few collisions, right? Less pressure, etc. But the more collisions you have, and the more that tightly packed in there you are, the more pressure you have. And so you would expect in the purely kinetic model it to be exactly equal to the ideal gas law. Then you add in the intermolecular forces, right? You get electron clouds, etc. You got these little gas particles. When they get really close, like in a high pressure chamber, they should, in theory, push away from each other, because you've got negative electrons pushing away from negative electrons with the electrostatic force. This should, in theory, add to the pressure of the system. So in reality, it should be a little bit more pressure than the ideal gas law. But in every pressurized container, even extremely high pressurized containers, which would have more intermolecular forces that we've ever measured, all the way until this day, every single contained system has slightly less pressure than predicted by the ideal gas law. There's some reasons for that. I just dropped a paper in the side chat. If you want to look at it, it's got a lot of relevant highlights. You can go through the highlights and see the relevant parts. But yeah, it's the ether theory of matter, the fluid dynamics theory of matter explains why that would be the case, because it's not a bunch of little billiard balls bouncing around. It's actually like little pockets or corpuscles or vortexes within a fluid medium, and the integral maths it out and shows why it would be that way. So
You went all the way for the big leagues, bro.
I think that's
Piezo
what
went
I
for the-
wanted.
And he kept it as condensed as possible, which I appreciate. So the big takeaway here, though, is that they have a model that of how they're accounting for gas pressure that includes a container and it doesn't include gravity, and even the way that it behaves in the container isn't aptly described. So to then apply it to the sky, like it's just going to fix everything as a uniform gravitational gradient, when there's direct contradictions to that in the lab, it just, it doesn't make sense to just say that as a belief, just have that as a belief system.
Tying it back together, yeah. Last point. And I think this will tie it back together a little more. The way you actually calculate the pressure, right? It's pressure along a surface, and the pressure is actually created by the change in momentum due to the reflection of the gas particle off of a surface or off of another
That's
gas
madness,
particle.
bro.
Right, and so you have to have a physical surface in order to create a change in momentum. Now you have that down at the bottom, right? You got the surface of the earth or whatever.